Assalamualaikum warahmatullahi wabarakatuh. Distinguished participants, ladies and gentlemen, in this session I will present my study on an application of defense in-depth concept for securing data transmission in radiation monitoring system for nuclear installation. My name is Nanang Triagung Edi Hermawan. I am from Indonesian Energy Regulatory Agency. This study also was supported by Mr. Edi Winarko and Mr. Ahmad Ashari from Department of Computer and Electronics, Gadjah Mada University, Yogyakarta. Let me introduce about the background of our study. We know that radiation monitoring should be conducted in nuclear installation. The system is a safety-related system. And we know that radiation monitoring data should be transmitted from the local sensor or station to the server. And in this transmission processing, the process generates security vulnerabilities, especially related to the data confidentiality and the data integrity. These cyber security vulnerabilities can seriously influence a whole safety and security of nuclear installation. So we should protect our data transmission from the attacker that could be influence the cyber security and then influence to the safety and security of our nuclear installation. We will conduct the protection by implementing different in-depth protects to protect our radiation monitoring data. In these slides, we can see about the system of radiation monitoring. We have system with the local sensor and the local station that they measure the radiation exposure and of course the radioactive release from the nuclear installation. Radiation monitoring data generates with the station or the sensor and then sent to the central server. We can use some of line or network in the transmission of data. We can use LAN network, we can use radio, satellites, and of course internet network. Our concern or focus of our study is in how to make the data transmission is secure, how to protect our data confidentiality, our data integrity in this processing. So we can make our first goal of our study that we want to create a comprehensive concept for protecting radiation monitoring data related to its data confidentiality and data integrity based on defense in-depth concept. And the second goal, we want to develop a secure authentication and encryption-decryption protocol to protect our data when transmit from local station to the central server. And methodology of our study, firstly, we conduct identification of the radiation monitoring system. We have to know about the specification technique of the application of the instruments, and by the transmission processing we identify the data transmission vulnerabilities related to confidentiality and integrity. And then we make defense in-depth concept implementation in our mechanism and develop a secure protocol framework. This protection of data implementing using cryptography. Let me make a small review about cryptography. Cryptography is a method of protecting data, information, and communication through the use of codes so that only those for whom the information is intended can read, can use, can access, or can process it. Cryptographic technique difference into three as asymmetric cryptography. It is used to protect our data confidentiality and to make sure authentication of identity or the source of the data. And the second, symmetric cryptography, it is used for protecting our data confidentiality. And the third is hash function. This algorithm used to make sure our data integrity. Based on the background, we can develop our defense in the framework. In the nuclear installation, we know that the fission products is protected by multiple barriers, so the fission products not released to the environment. In the system, the multiple barriers used such as from the matrix of the fuel, and then the cladding, and then the primer cooling, and then the confinement. So, like the system, we can implement the defense in-depth to protect our radiation monitoring data. The data should be make sure about the confidentiality, about the authentication of authentication, and about the integrity of the data. So we implement multi-layers protection of data related to data source by authentication of entity protocol, and then we make sure related to data confidentiality using cryptography, and then to make sure data integrity we use hash function. And of course, for the line that using to transmit radiation monitoring data from local station to the server, we use the secure lines. Like in the case we use VPN, virtual private network. This slide is describe about our protocol for authentication. The source of the data, the real sensor, the authorized sensor, should be authorized firstly before they join to the system. So we can make sure that the radiation monitoring data come from the authorized or the registered sensor, not from the attacker or the others. And this is a description about our protocol for make sure the security of the data. In this mechanism, we transmit our radiation monitoring data by encrypting using IS algorithm, and to make sure the integrity, we implement hash function is in this protocol. So only data from the authenticated ADMS can be received by the server. The server will not receive the data from unauthenticated ADMS by the mechanism. This is some defense in-depth implementation from our system to transmit the radiation monitoring data. So from our discussion in this session, we can conclude that transmission of radiation monitoring data has security vulnerabilities related to data confidentiality, data integrity, and data availability. And then for protecting data confidentiality and integrity, combination and integration of virtual private network client, authentication, encryption, decryption, and hash function mechanism should be conducted. Some crypto system algorithms such as RSA, AES, and hash function can be implemented to achieve the security goals. I think that's all our presentation. Thank you so much for your attention.